For decades, automotive giants like Toyota have led the industry, not only by offering cars that cater to every budget and preference, but also by producing some of the best engines on the market. Their latest innovation, the hydrogen fuel cell engine, is focused on carbon neutrality and efficiency, exactly what the industry needs. Toyota's engine legacy stretches back to the 1930s, initially producing engines for their vehicles and other manufacturers. Today, Toyota engines power everything from compact cars to trucks and SUVs. Subscribe for more updates and deep dives into the latest automotive tech. Don't miss out. Hit that button now. In 2015, Toyota set a bold goal with its environmental challenge 2050, aiming to reduce CO2 emissions across the entire vehicle lifecycle, production, usage, and recycling. Their vision is that environmental vehicles are only effective if they become mainstream and contribute to significant CO2 reduction. To achieve this, Toyota is heavily investing in electric vehicles, hydrogen fuel cell technology, and renewable energy. Their new hydrogen-powered engine, which emits only water vapor, offers a cleaner and more sustainable alternative to fossil fuels. In this video, we'll explore what this breakthrough means for the auto industry and car owners, along with its potential benefits and challenges. Stay tuned. What makes Toyota stand out is its relentless drive for innovation. As one of the first companies to introduce hybrid vehicles, they continue to lead the charge in developing hybrid and electric technology. Their hybrid system, which combines a gasoline engine and an electric motor, boosts fuel efficiency and cuts emissions. The Toyota Prius, for example, remains a top choice for eco-conscious drivers. Toyota also takes safety seriously, with many of its models earning top ratings from the National Highway Traffic Safety Administration. But it's not just about the cars, it's about the engines. From their early efforts in 1934, Toyota's engines have been a testament to innovation, with their first prototype delivering 65 horsepower, outperforming the competition. Now, they're taking the next leap toward a greener, more sustainable future. From that time on, Toyota never looked back. In 1992, the Japanese company started researching fuel cell engines, but it wasn't until 2013 at the Tokyo Motor Show that the company presented its first hydrogen-powered fuel cell concept car to the public. The vehicle took roughly 3 minutes to refuel, about the same as a gasoline car, and the fuel cell system was equipped with Toyota's high-efficiency boost converter. It also featured a fuel cell system with an output power density of 3 kilowatts per liter, delivering an output power of more than 100 kilowatts, and used Toyota's proprietary lightweight fuel cell stack and 270 megapascals high-pressure hydrogen tanks placed beneath the specially designed body. The 2021 Toyota Mirai took FCEV technology to another level. Combined with innovative packaging and better aerodynamic efficiency, it increased the driving range to almost 650 kilometers with no emissions other than clean water. Before we get into further details, let's explain what a fuel cell engine is. A fuel cell engine is a device that converts chemical energy from a fuel like hydrogen, as in the case of Toyota, into electricity through a process called electrolysis. The electricity generated can then be used to power an electric motor, which can drive a vehicle or other equipment. Fuel cells work by having two electrodes, an anode and a cathode, separated by an electrolyte. The fuel, typically hydrogen, is supplied to the anode, where a catalyst causes the hydrogen molecules to split into protons and electrons. The protons can pass through the electrolyte to the cathode, while the electrons are forced to take an external circuit, creating an electrical current. At the cathode, oxygen from the air is supplied and reacts with the protons and electrons, creating water and heat as byproducts. One of the main advantages of fuel cells is that they're highly efficient and produce little to no pollution, as the only byproducts are water and heat. They also have a high energy density, which means they can store a lot of energy in a small space. This makes them ideal for use in vehicles, as they can provide power for the electric motor while taking up less space than traditional internal combustion engines. The Mirai did not perform so well for many reasons, so Toyota had to devise a new way of using hydrogen to power their engines. This time, not as a fuel cell, but as the fuel in a combustion engine. The difference is that the fuel cell is an application of hydrogen as an electrochemical substance, not a combustible fuel. The hydrogen internal combustion engine is a modified version of the traditional gasoline-powered internal combustion engine and was born out of the 1.6-litre turbocharged three-cylinder already seen in the GR Yaris and the GR Corolla. What Toyota did was modify the 1.6-litre turbocharged three-cylinder with the addition of a heavy-duty fuel tank to contain the hydrogen under high pressure and develop a new prototype hydrogen internal combustion engine car called the Corolla Cross H2 concept.